Okay, welcome to Lecture 2 of Week 10 of the Online Statistics class. And today the plan is we're going to do Part 2 of regression analysis. So the plan is we're going to be looking at the regression line. So when you think of a line, Shirley, what do you think of in algebra? If you want to talk about a line, what are the different words that come to your mind that happen in algebra? Logarithmic. Okay, maybe, but I'm thinking about lines, straight lines, very basic algebra. That's a logarithmic is a little too advanced. Okay, definitely points, and that's where scatter plots come in, which we did. And I'm hoping that you might think about slope, because that's a big piece of lines, and maybe intercepts, especially the y-intercept is something that you deal with in lines. Does that ring a bell, hopefully? Okay, we're going to be looking at lines in a much more practical way than you look at it in an algebra class. In an algebra class, you find an equation, you write it down, you box your answer of the equation, but you don't do much with it. What we're going to actually do is do things with the lines. See, why do you really care about lines? And we're going to be looking at a few things. First, we'll look at what's called residuals, and that'll help us on finding the perfect line, the least squares regression line. So least squares regression line. And then we'll have a prediction interval, which is a little like the confidence interval. But before I start, and this is the first time I've done this, but I'm hoping this works out, is I want you, and everyone who's watching this also, I want you to watch this YouTube video because it's much better than anything I could do or anyone could do individually on a short online class. They've really put a lot of effort into this. This is a 5-minute video, and this should be clickable. This should be clickable. So Shirley, give it a click, and give me a happy face when you're able to play it. So you should be able to click this. And it should pop up a YouTube video. And I want you to watch this about 5 minutes, and then I'll be quiet for 5 minutes, and as that happy face pops up, so that you can watch this YouTube video and not have to listen to me. And hopefully it's clickable. It's a blank square, really? Okay, well, let's do it a different way then. I'll make it clickable in, okay. I never know what you see versus what I see. Let's try one more different way. Let me click it in your chat box. Okay, that should be clickable. Try that one. It's interesting with the blank square because I don't see a blank square. I see a clickable thing. If I show you the video, that doesn't work very well with this connection. So it's a lot better for me to show you the link, give you 5 minutes, and then you come back, let me know that you watched it, and then we'll talk about it. And so give me a happy face when you're able to click play. So in the chat box, there's a link. Okay, and again, those are watching the archive video, you want to watch this also. So this is a big introduction on what we're going to be doing. It's kind of the week's theme. Surely I'm not seeing a happy face, but I'm not sure I'm seeing a sad face either, so that might be all right. Okay. So again, if you can't click it, you can copy and paste it in their browser, and that should work also. So any luck, Shirley? I'm not seeing any action on your part. I'm hoping you're getting it. So I think if you click on it, it should just pop up. Yep, that works for me. Maybe you're watching it. I'm hoping that means you're watching it, because once it's up, you have to minimize to be able to bring it back down and then tell me you're watching. So hopefully in 5 minutes you'll come back in. Aha, it looks like you're back alive. And it's been about 5 minutes, and that might be a good sign. Okay, couldn't get to the class screen to give you a smiley face. Oh, good. Okay, so you watched it? You viewed it? Okay, so what did you get out of that? Because that's really the theme of the whole week. What did you get out of that video? Because this really is how statistics should be used to display data. Now, there's no way in the world any one of us could do something that amazing, because that probably involved, thousands of dollars of work and hundreds of hours of time. But what did you get out of that in terms of displaying data? Right, it was showing data from multiple countries over a period of time, and you'll notice that the dots there, this is what we did last time, but we have a name for it, those the way they displayed it was a big scatter diagram or scatter plot. And what we're going to be looking at further today is how to understand these kinds of graphs. And again, I don't have the technical skills to be able to do that fancy. That's why I showed it in this lecture, because I think it was worth it. But let me move on and talk about something that's a little less interesting, but kind of gets to what we're doing and what they're talking about also. One of the big things that was happening in that video was looking at trends. In the video, they were talking about what happens as countries have more money. Okay? And they found out that as countries have more money, they tend to, but not exactly always, but they tend to have a longer lifespan as a national average lifespan. And hopefully you got that out of the video instead of just kind of a cool accent. But hopefully you noticed that if you were kind of low on the income scale as a country, you would also be low on the health scale, okay, how long you live. And there are anomalies, and then they went through time. The interesting thing about that is there was really another axis too, and that was a time axis. So if you look at time versus how long you live, that also increased. But not always for every data. For example, they showed when World War II and the Spanish flu came along, there was a big drop suddenly. Then it came back up. And that's typically what happens when you're talking about data, is it's not perfectly, the trend isn't perfect, but you just notice that as time goes on, there tends to be an increase or decrease in some variable. Okay, so what I want to look at is what's called the regression line. And for now, I'm just going to draw it and tell you that's what it is. And then pretty soon we'll look at understanding it a little bit more. So what I have here is I have some data points. These are the little blue points. I'm not sure if you can see them, but they're the tops or the bottoms of these red lines. Here, 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 and here. And then what I did is I drew a line that seemed to be a good fit for the data, or as best I could find. Any questions on that? Okay, so here's the question for you. When I say good fit, what does a good fit mean? Or even best fit? So what does best fit mean? Okay, you can kind of visualize this line, but what does it mean? I mean, why not a different line? Why couldn't you just look at that line? Would that be a good fit? Okay, and the question is, what does it mean to have a good fitting line versus a line that's not good? And it turns out there will be a best fitting line, which I have actually drawn using the computer, of course. And it looks like you're typing and giving an idea of what good fit might mean. Okay, straight line, which includes the best relation to the point. Okay, and that's definitely what's going on. But the question is, what does it mean to say best relation? Okay, that's kind of saying best fitting or best relation. But what does best relation mean? And that's the next question. It doesn't look like you're typing because that's hard to answer. Okay, or maybe you are typing, you just slow at the gun. Okay, so the question is, what does it mean to say best fit? Okay, it looks pretty on paper. All right, well that's good, but I can put little hearts on this other line or something. Here we go. Do I have them? Ah, here we go. Here, I'll put some stars on it to make it really pretty. But just because it's pretty doesn't make it a good fit. Okay, that looks pretty on paper, but it's not a good fit. Okay, so it's not quite that it looks pretty, but it's somehow best fitting, and this is why we got to talk about what's called residuals. And residuals are going to tell us, in a way, how good the fit of a line is. Okay, so in particular, if you look at the points, so here's a point right here. And you look at the vertical distance from the point to the line. That's where I've drawn these little red line segments. Those distances are called the residuals. So you'll notice that we have some residuals that are real small, like this one. And then we also have some larger residuals, like this one. Okay. If I tried to use a different line, like the one I have in black with the pretty stars, the problem is, if you look at the residuals, some of these residuals will be very large. There we go. So some of these residuals will be very large. Those are supposed to be vertical, by the way. And what we want to do is we don't want to have large residuals. We want to have small residuals. Any questions on that idea? Okay, so the best fitting line is going to be the line with the smallest residuals. Okay, and in terms of what that means in specifically, it's the following. So the least squares regression line is a line that has the smallest sum of the squares of the residuals. Okay, and again, leave the math up to the mathematicians and just, shake your head and say, yeah, sure, I believe it. Okay, but instead of adding up all the residuals, it turns out you want to add up the squares of the residuals. And again, just trust me that it's the right thing to do. Okay, and here's the notation we're going to use. So you're used to y equals mx plus b, probably. Have you heard of that before, y equals mx plus b? Okay, I thought so. I hope so. Otherwise, you probably don't belong in this class because algebra is a prereq. So all I'm doing is I'm writing down that equation y equals mx plus b, but in kind of fancier terminology. So instead of y, we're going to use y with a hat on top of it. And again, that's just standard terminology. And what that hat means is that is going to be the estimated y from the regression point. So it kind of gives it a little more meaning than just y. And then m, in this case, is the slope, which is always a number in front of x. So in this case, I'm calling it b1. It has lots of names. Sometimes you'll call it a plus bx also. As we'll see if the calculator calls it a little different. Everyone calls it a little differently. And then this b naught is going to be the y-intercept. Any questions on the equation of the regression line? Any questions on it? Okay, so the slope of the regression line, that's at b1. Well, hopefully you remember. So give me a happy face if you remember that the slope is rise over run, if that means something to you. Okay, I thought so. Okay, the slope is a rise over run. Okay? So what we often do in statistics is we think about the run being 1. It just makes it easier to talk about. So if x changes by 1, that's what run is. Run is a change in x. So if x changes in 1, then y tends to change by the slope. Because y is the change in y is the rise, the change in run, the change in x is the run. Okay, and the y-intercept, that's when x is 0. So the y-intercept is the value of y when x equals 0. Now, what you're probably not used to doing is thinking about what this really means when you're talking about using a line. And that's what I have for you next. Okay, so here's the first thing. Is in the example I've got, which don't quote me because I made it up, is a study was done to look at the relationship between packs of cigarettes smoked per day and how long a person lives. Okay, sounds like a good study to do. Okay, the equation of the regression line is y hat equals 84 minus 3x. So the first question I have is use the regression line to predict how long a person who smokes 4 packs a day will live. So Shirley, do you have an idea how you might do that? And the hint is it's easy. So let me know if you have an idea or if you don't have an idea. So how would you use the regression line to predict how long a person who smokes 4 packs a day will live? I'm not seeing you typing, which I'm worried about. So let me know if you have an idea on what that might be, or if you have no idea, that's fine too. Okay, you're not sure? Okay, so the idea is we look at what's given, and what we want is how long a person who smokes 4 packs a day. So first, smokes 4 packs a day. So let's read the question again and see what that represents. So smoking 4 packs a day, is that going to be X or is that going to be Y? What do you think? So do you think it's going to be X or Y? That number 4. That's going to be X. The reason why we know it's X is the independent variable. So in other words, if we know how many packs someone smokes, then we can give a guess or an inference on how long they'll live. Okay, it doesn't quite work the other way very well. If you know someone lived to 90, you can't really guess at how much they smoked. You see, so typically smoking is the one that is going to be a predictor of early death. So that tells us X is equal to 4. So now does that help you figure out what to do with this, if we want to know how long a person lives? Okay, solve for Y, or just get Y. It's not really algebra, it's more arithmetic at this point. So see if you can do that. Good, good. So what we would say is that based on the regression line, we can predict that a person who smokes 4 packs a day will live 72 years old. Okay, now does that mean that if you smoke 4 packs a day, you're going to live 72 years old? Definitely not. There's people who live to 100, there's people who die at 30. What it tells you is that our best prediction for how long a person will live will be 72 years old. So prediction is very different than a definitive knowledge. Any questions on the difference between the two? Okay, so next is we want to interpret the slope. So first thing, what is the slope, Shirley? What's the slope equal to? Right, the slope is 3, so that's the first thing. So interpret doesn't mean what is the slope, but you have to know the slope to interpret it. I'm going to write m equals 3. You're used to m being slope because we know French. Okay, and now we want to interpret the slope. So let's write this out. So remember that m is the rise over the run. Any questions on that? Okay, and the rise over the run, if we think of the run being 1, because remember it's easier to interpret it to have 1 as the run, then the rise, let's have about 3, then the rise will be 3. Any questions on that? Okay, but we can also think about this in words, and it helps to write down the words. And the words I'm going to write are, the rise is, again, the change in Y. Well, Y is lifespan, okay, or age of death. Lifespan sounds a little nicer, that's all. And the run, so lifespan change, and the run is going to be the change in packs of cigarettes. Okay, so that's packs of cigarettes. Any questions on that so far? Any questions so far? Okay, so now if we read this, we say that for every pack of cigarette, right, we have a 1 pack of cigarettes, so for every pack. So for every pack of cigarettes, or additional pack of cigarettes, a person smokes per day, their expected lifespan, actually, sorry, I missed that. The rise was -3. The slope is not 3, it's -3. So that's probably when I blindly listen. Do you see why the slope is -3? Okay, so again, what we can say is that for every additional pack of cigarettes a person smokes per day, their expected lifespan will decrease, negative or decreases, by 3 years. Any questions on how to interpret the slope here? It takes a little while to get used to it, and you want to practice these. Okay, especially since I always ask these on tests. So any questions, Shirley? Does that make sense, or is that confusing? Looks like you're typing. Okay, you're following slowly. Okay, good. Well, at least you're following. Okay, so again, the change in cigarettes is 1. The change in cigarettes is 1, and the change in lifespan is -3. So 1 additional pack of cigarettes, you expect -3 lifespan, or a decrease of 3 years in living. Any questions on that? Okay, so now let's go and talk about what the y-intercept means, because that's the other big piece that you talk about with lines. So for the y-intercept, remember the y-intercept means x is 0. Okay, so if x is 0, what is y? What is the y-intercept? Looks like you're typing. So if x is 0, what will the y-intercept be? Good, 84. Okay, so if x is 0, y is 84. So now I'm going to put this into words. So x is 0. What does that mean in words for this person? What can you say about this person if x is 0? Right, they're not a smoker, because that means they smoke 0 packs a day. They're not smokers. And if y equals 84, what does that mean in words? Okay, good. The person is expected to live 84 years. Good, good. So in words, in total words, what we can write is that non-smokers, write a little lower, about here, are expected, or predicted is probably even better, to live 84 years old, 84 years. Any questions on that? On how to interpret the slope and interpret the y-intercept? So again, this is kind of a different way of looking at lines. In algebra, you just find equations. Not very useful. But in statistics, I think it's a lot more useful. You understand why you care about a line. And you care about a line because the slope and y-intercept really does have meaning. Okay, any questions on that before I move on? Okay, so let's move on. Okay, so now that we've got that, now let's pick another one. Okay, so here's another example. It says a realtor is looking at the relationship between the year and the population in thousands of South Lake Tahoe. The equation of the regression line is y hat equals -975 plus a half x. And by the way, later we'll find out how to find this equation using our calculator. Right now I'm just giving it to you. Okay, so the first question is use the regression line to predict the population that happened in the year 2000. And let's see if you could do that. You may need your calculator. You may be able to do it in your head or by hand. And let's see if you can use the regression line to predict the population in the year 2000. And I'll type out the answer, but not show it to you until you give it to me. Good, good. So we take negative 975 plus 1.5 times 2,000, and you could drop it in your calculator or do it by hand, and you get 25. And remember, this is in thousands, so the population of South Tahoe was about 25,000 people in the year 2000. Any questions on that? Okay, now let's interpret the slope. That's the next question. So interpret the slope. So any thoughts on that, Shirley? Do you want to type that out? If you start typing, then I'll start typing also. Okay, the slope is a half, but interpret slope means give me a complete sentence that tells you what that means in the context of this question. So you write that the slope is a half. So any thoughts on that? Maybe I'll start typing, and that might get you thinking too. Okay, population size is part of it. So let me say what I've got, and that is on average, because that's what we got, averages and predictions, that's what we're talking about for this material. On average, the population has increased around 500 people per year. How did I get 500 out of that? Any thoughts? Okay, population divided by the number of years. Not quite. It's the population is in thousands, and half a thousand is 500. Is that confusing or is that clear? Okay, so the population is given in thousands. It says that. The slope is a half. So 1/2 of 1,000 is 500. Good, good. Just like the answer, the population wasn't really 25, it was 25,000. So everything has to be multiplied by 1,000. Okay, now comes something a little more interesting. That is, interpret the y-intercept. So Shirley, what's your thoughts on the y-intercept? So first, what is the y-intercept? Okay, 25,000. 25,000 was the prediction in the year 2000. But the y-intercept, remember, we've got to get by definition, that's the value of y when x is equal to 0. Does that help? So now, what is the y-intercept? Negative 975. And actually, negative 975,000 people, as you would say. So how do you interpret that? It's kind of a trick question. That's a hint. And let me type it out as you're typing it out. I don't see you typing, so maybe you're not sure. And now you're typing, which is good. Okay, current population is not quite. So let me tell you the answer. Tells you the trick question. The y-intercept has no meaning. The reason is you can't have a population of negative 975,000. Doesn't make any sense, does it? These are populations, number of people. Okay, and in fact, do you know the real y-intercept? Do you know what the, that's why you're hesitating. I told you the trick question, which means go for the trick. Okay, so do you happen to know what the population was in the year 0? Because that's what the y-intercept means, the year 0, which is 2011 years ago. So do you know what the population of South Lake Tahoe, the permanent resident population of South Lake Tahoe was in the year 0? It was 0. Nobody lived in Tahoe in the year 0. The natives would come up in the summertime, the Washoe Indians actually, but in the wintertime it was too cold to live here. Remember, there was no electricity or any of those nice things that would get you there, and there's no food up here either in the winter. So the year 0, the population was 0. Too harsh. Okay, so it doesn't make any sense. So sometimes the y-intercept has an interpretation, and sometimes it does not. The slope always has an interpretation. Any questions on that before I move on a bit? Okay, let me move on. Okay, the next thing to talk about is what's called the prediction interval. So remember that the first question, part A of these last two, were to make a prediction on using the regression equation based on some value of x. And the problem is that's a prediction, but there's going to be variation. It's not going to be perfect. So we want kind of like a confidence interval for that prediction. And we call it a prediction interval. And it's the following. This is how you interpret it. So we can use the regression line to predict y given x. And this is just a prediction and has error. So we can form a confidence interval for this y given x. If r squared is large, that's what we talked about last time actually. So if the regression line is close to the points, then it's useful to use the value of y to predict value of x to predict y. Otherwise, it's not useful. Any questions on that idea? Any questions? Okay, if you don't have questions, let me move on and let's find one of these guys. Okay, so here's the question I got for you. Data was taken to see the relationship between the price that a motel charges and the number of rooms that are filled. Okay, real important if you're a manager of a motel. You want to decide how much you're going to charge because you want to maximize profit, basically. So the data is shown below. Find a prediction interval for the number of rooms filled when the motel charges $80 per room. Any questions on the question? Any questions? Okay, so now we're going to have to crunch out numbers. Okay, so we're going to crunch out numbers, and I'm going to show you all kinds of stuff you can do with the calculator. So we have price and rooms, and that's what I'm going to put into L1 and L2. And we're going to be using our lin reg t int. And if I remember right, that may be hard to find. Let me just check something. And you may have it in your calculator. Hopefully you do. Otherwise, you may have to go look on the internet and find it to download. Just a minute. Let me share my desktop so you can see my calculator. Okay. So, Shirley, what kind of calculator do you have? Looks like you're typing. T83 Plus. Okay, so we'll see if it has it. Hopefully it does. So the first thing you do is you clear your list out. You're used to that. Okay, and then I type in my data. So in L1, I'm going to type in the price, because that's my X variable. And I had 40, 40, 50, 50, 60, 65, 70, 75. Then I had 85, 85. Then 90, 95. And then I had 100, 100. Then 105, 110. Okay, those are my prices. It looks like I missed on that 110. That's better. And then for L2, I have my number of rooms rented out, okay, or checked out. And that is 92, 80, and then I had 85, 81, and then 78, 75, 80, 65, 50, 55, 60, 49, 45, 50, 52, 35. Okay, give me a happy face if you've got your data entered. Oh, good, good. Okay, so now once I have my data entered, I go to Stat, tests. And the up arrow is faster. So if you go up arrow, hopefully you'll see linreg tint. So give me a happy face if it's on your calculator. I hope it is. If not, you may have to program it in. And if that face is not there. Still looking for it? So linreg tint. Yeah, you need tint, not t-test. Do you not have it? Okay, well follow along with me and then maybe you can program it in. I'll look for a link to see if there's an explanation of how to program it in. It shouldn't be that hard. So if I hit enter, then L1 and L2 are my X and Y, frequency 1. I'm going to go for 95% confidence interval because that's kind of what your typical confidence is. And then just go to calculate. Okay? And notice I get a bunch of stuff. One thing I get, which is really important, you'll see Y equals A plus BX here. And that, the next line, not the next line, but down here it tells you what A is. A is 117, and then B is later, I think. Does it not tell you B? How can it not tell you B? There it is. B is negative 0.69. So B is the slope of the regression line, negative 0.69. You raise the price, you're going to have fewer people coming into your hotel. That would be expected. And then A is 117.24. So that's a little weird. That's the predicted number of rooms rented out when you don't charge any money. Okay, and what you might expect is that might be the number of rooms in your hotel. Okay, but more importantly, we have a negative 8279. Just a minute. We have R squared R. I think I need one more thing. Let me go back and see. I think I made a mistake on that. Let me go back to my stat because it shouldn't be negative. Linreg tint. There should be one more thing. L1, L2, frequency 1, 0.95, regression equation, calculate. Where is the number you got to plug in? I'm going to have to get back to you on that on the calculator. Thought I had this. Okay, so we have A and B, and that's the important thing is to know that how to find the equation of the regression line. Okay, and what this is negative 0.8279 to 0.5557. That's going to be if you subtract those two numbers, that will give you the width of your interval. Any questions on that? So the width of our interval is 0.27 about. So if we take negative 0.5557 minus negative 0.8279, we subtract those two numbers, that will give you the width of your confidence interval. Okay, and that width is about 0.27. Okay, or about 0.14 on either side. So in particular, since we have A plus BX, if we want to predict for $80, that means we're going to plug in 80 into the equation. Okay, so let me put in the chat box because I'm going to go back to what I need. So we had a width was equal to 0.27. We had our A was equal to, or we had our Y equals A plus BX, and A was 117 plus B was minus 0.69 X. So now if I go back, and we'll be able to see it in the context of the question. If I plug in 80, I get 117 minus 0.69 times 80. And you'll probably need your calculator for that. And what do you get? So when you plug in 80 into the equation, what do you get, Shirley? Good, 61.8. And our width was 0.27, or about 0.14 on either side. So if we subtract 0.14 on either side, or about 0.1, then you get a confidence interval of the following: 61.8, 61.7 to 61.62. Any questions on that? Okay, so again, that's how you get the equation of the regression line and kind of get this prediction interval. Okay, we could do it again. I'm not sure if I want to do another example because I think I want to spend the last few minutes. We got about 4 or 5 minutes to talk about the project a bit, because I'm hearing a lot of things that are. Some of you are really struggling over the over what your null hypothesis and alternative hypotheses are, how to come up with them. Okay, and Shirley, I'm trying to remember. Do you have your project started out yet? Okay, and what was your, just so you can tell everyone else, you can't use Shirley's, by the way, unless you're Shirley's partner. So what was your H0 and what was your H1? And you can give me in words and symbols, either way. I want to spend a little time talking about the project, or HA. I would call it H1, so I'm used to that from the old book. Okay? So age of first real kiss, but there's a little more than that, if I remember right. Because you need an H0 and an HA. Okay, looking for male-female comparison. Okay, so if you do a comparison study, then almost always you're going to say that mu1 is equal to mu2. And what do you think? Do you think men wait longer, or do you think women wait longer? Or in today's society, it's more boys and girls. Okay, all right. So this is a flaw. You shouldn't. You should never do the survey until after you've decided on your HA. So in your HA, what did you think originally? Never change it after you do your survey. You start out with H0 and HA, and then you do the survey. So what was your HA before you did the survey? That's the important thing. Okay, so your HA. So don't change it. Remember, you're not graded on whether or not you reject your null hypothesis. You're graded on whether you understand how to interpret your survey. So your HA would be mu1 if mu1 is, say, boys, is less than mu2. And that means that mu1 is boys' age and mu2 girls' age. Okay, so don't change your hypothesis after you have done the study. So the idea is once you set your hypotheses, then you go and do the study, and then don't change it. Any questions on that? Okay, so secondly, what I've seen some people do is they want to do a one sample or one population study. And you could do that, but your null hypothesis has to come from something. It can't be, well, I just feel it this way. It has to come from something very specific. Okay? It could be an article you read in some magazine, okay, where it said what the average age of something was. Or it might be what is recommended by the government, that this is the average number of servings of vegetables you should get. Okay? And then you're going to have a valid H0. But what you don't want to do is just say, well, I wanted to see if people kiss after 14 years old. Okay? Well, why 14? Okay? So unless there's a reason, then it's not a good project. Okay? If you're doing a comparison study, then you want to see if boys are kissing earlier than girls. Okay? And then that makes sense. So the comparison study is really easier to come up with a hypothesis. If you do a single sample study, then you need to have noticed something from reading something about a mean. And again, that happens, but it's kind of unusual. Okay, I want to see if people speed on the freeway. Well, then you got to look at the speed limit on the freeway and clock a bunch of people. Okay, and then there's a natural speed that people are supposed to go, and there's a natural H-naught. So that's really important when you're coming up with your null hypothesis and alternative hypotheses, is to make sure that if you're doing a single sample study, there's a natural H-naught, otherwise it's not a good project. Also, it must be a mean, and surely you got a mean, which is good. So you must have a mean. So your survey question or your data collection has to be quantitative. There should be a bunch of numbers when you're done, not a bunch of yeses and nos. Any questions on that, or any questions at all on your project so far, Shirley? Okay. Also, and I'm not sure why people ask, but people do ask when it is due. That's on the syllabus. And on the syllabus, it says, which I'm reading right now, by the way. You can't see that I'm reading it. But I'm going right to the syllabus so I don't misquote it. Is Project 2 is due December 1st. So Project 2 is due December 1st. Let me get to CC Convert again. Okay. Okay, so not so far. I'm sure we have questions soon. Okay, yeah. So if you have questions, let me know. Of course, I'm always checking. Except this weekend, I'll be off Thursday, Friday, Saturday without looking at the internet. That's not like me, but it is on Thanksgiving. So Project 2 is due December 1st. And I recommend at least a few days earlier, let me look at it, your first draft. So recommend giving me or sending me your first draft a few days before, at least a few days before. Okay. One of the things that you'll probably struggle with is interpret a full paragraph interpretation of the standard error. So that'll be a struggle. That'll probably be the hardest part of this whole test, because that's a concept that's tough to understand. But do your best, and then if you get stuck, I can help you a little bit. I won't write it for you, but I'll give you some pointers. Okay, so that's real important to talk about the standard error. Another thing that I want to remind you on is the final exam. So final exam must be taken, and I emailed everyone about this, by December 7th. That's a Wednesday, not a Thursday, by the way. After December 7th, if you don't take it by December 7th, it's just a 0. And basically you don't pass this class. So you could take it earlier, you could just take it December 6th or December 5th or December 4th or December 3rd. On December 1st, I'll be giving a review for the exam. So any questions, Shirley, before we go? I should give you a word of the day. I forgot about that. So secret word. You have one more chapter, but it's just one section of a chapter. A very short chapter left. Good question. There is one more chapter. It's a short one, not very hard. So secret word is regression. Okay, which is kind of the name of the title of that line that we use. The best fitting line. Okay, any other questions, Shirley? Okay, have a great Thanksgiving. Hopefully everybody gains about 5 pounds and has a good time. That's always the goal on Thanksgiving. And then you could work it out the day after. Take a jog or something. Okay, bye, Shirley. Thanks for coming. Okay, for those who are watching this as an archive video, thanks for tuning in. And I shall see you next week. Everyone have a wonderful Thanksgiving. And next week is our last week of regular webinar class, and then it's just the final. So hopefully this is the time to gear up and ask me questions when they come up. So take care.